Hello everyone. Today our discussion will be on Open Shortest Path First algorithm, OSPF. OSPF is a dynamic routing algorithm. So first let me discuss about the VLSM that is required for OSPF configuration, and then we will see the configuration in Cisco packet tracer. I am going to use a class C IP address 192.168.10.0/24, which is the subnet mask. So an organization requirement is going to be, it needs 5 subnets. Subnet A require 5 hosts, B 30, C 10, D 5 and E 2 respectively. So I have manipulated a table. In the table I have entered the subnets, number of hosts required. After getting the number of hosts required, we can find out the number of host bits that we have to take for consideration. The remaining bits we can give for the subnetting. For subnet A, the number of hosts required is 50. So 2 power 6 is equal to 64. So among 8 bits, that is the last octet 8 bits, among 8 bits, we can give 6 bits for the host and remaining 2 bits we can add it to the network. So our subnet mask is 24, right? /24, to that we can add +2. So it is going to be 26. For subnet B, the host requirement is 30. So we need 2 power 5, which is equal to 32 hosts we can accommodate for subnet B. So here we are going to use only 5 bits for the host. So the remaining 3 bits, that is 8 minus 5 is equal to 3. The 3 bits we can give it for the network. So 24 plus 3 is going to be 27. Likewise for subnet C, the requirement is 10. 2 power 4 is equal to 16. So only 4 bits we are going to use for the host. The remaining bits we can give it for the network. So 24 plus 4 is going to give you 28. Likewise for subnet D, 5 bits we need. 2 power 3 is equal to 8. So 3 bits we can give it for the host and remaining bits we can give it for the network. So 8 minus 3 is equal to 5. 24 plus 5 is going to give you 29. And likewise the last subnet requirement is E, which is 2 hosts are required. So the number of bits we have to get for the host is 2. 2 power 2 is equal to 4. So 8 minus 2 is going to be equal to 6. So that 6 bits we can include for the network. So 24 plus 6 is equal to 30. So you know how to find out the subnet mask. If you have any doubt, you can check my previous video. I have given in the description box. So the subnet mask is given. The first 3 octet will be only ones, and in the third octet the first 2 bits will be ones and the remaining will be zeros. So for the first bit it will be 2 power 7, which is equal to 128, and the 7th bit will be 2 power 6, which is equal to 64. So 128 plus 64 is going to give you 198. So likewise you can find the subnet mask for each and every subnets. So after you get the subnet mask, it will be you can find out the network address. So the requirement is for the first subnet is 50, right? So the given subnet network address is 192.168.10.0. So to that that will be the first subnet address. To that, if you add these 64 bits, you will get the network address for the second network. Similarly, to this 64, if you add this 32, you will get the network address for the subnet C. That is 64 plus 32 is 96. Then for the subnet D, to find the network address, add this 96 with this 16. It is 112. Okay. Similarly, you can do it for subnet E also. Once the network address is known, it will be easy for you to find out the address range, because dot zeros will be the network address. So the address range for the host will be from dot 1. Okay. So it is from dot 1 till dot 62, because dot 63 will be the broadcast address. Okay. So similarly I have given all the address range for the 5 subnets. Only difference what we have to note down in case of OSPF is, in OSPF it will be using the wildcard mask. That means it is a inverted subnet mask. It acts as an inverted subnet mask, but with wildcard mask the 0 bits indicates network part and 1 bits represent the host part. Okay, just you have to invert it. So when we consider the subnet mask, the first 3 octet will be 1s, but in case of wildcard mask, the first 3 octet will be 0s and the last octet will be 63. Okay, so for the second subnet also, we have the subnet mask 255.255.255.224, right? So the first 3 octet will be inverted to zeros, and 224 we got it by the first 3 bits, right? So we have to consider only the remaining bits for the wildcard mask. So what will be the wildcard mask here? It will be 0.0.0.31. Okay, so this 31 plus 224 will give you what? 225. Okay, similarly for the next one it will be 0.0.0.15. Okay, so 15 plus 240 is going to give you 255. Similarly for the next one, 0.0.7. For the last one it is going to be 0.0.0.3. Okay, so this is the very important part in OSPF. Without wildcard mask you can't configure the network. Okay, so for OSPF configuration, today my plan is to have 2 routers. To both the routers I am going to add 2 different networks. Okay, so first we will add the routers. I have added 2 routers. Now we will add the switches. I am going to add 2 network to each of the routers. Okay, so I have taken 4 switches, and then I am going to take the PCs. So each switch I am going to connect to PC. Okay, so now we will do the connections. Okay, so we have connected the switches on the PCs. Now we will connect the router on the switch. Okay, router and the switches are connected. Okay, now we have to connect the router and the router. So for that I am going to use a serial connection. Okay, so we will add the serial port. Click the router, go to configuration, physical, switch off, choose the module, and then drag and drop the port, switch on. Similarly for router 2, I am going to switch off and choose the module, drag and drop the port, switch on, close it. Okay, now we can add the serial ports. We have done the serial connection. Now we can add the IP addresses. So before that I'll make a note for each and every network. So we are going to use 192.168.10.0. This is the first network. Okay, maybe I can represent the network name. For the next one it is going to be .64. So it is a good practice that if you maintain nodes, when it goes to a very big configuration, you may get confused. Okay. See, it is 96. It is D. The last one is E. Sorry, this one I didn't make the change. It is 112, and last one is E. It is 120. Okay, so now we'll assign the IP address to the PCs. Click the PC, desktop, 192.168.10. Second address I'm going to give for the PC, because first address I'll be assigning for the network, and after that the next first address will be given to the gateway, and the next address will be given for the PCs. Okay, so here I'm going to use .2, and here the subnet mask is .192.168.10.1. okay, close it. For the next PC, three 192 is the subnet mask, gateway will be .1. okay, and now this network we have assigned IP address for the PCs. Coming to the next network, desktop, so 64 is the network address, 65 for the gateway, so here this we'll use 66. Here the subnet mask is 224, 65, close it. I'm going to give 66, sorry, 66 is already used, so here it is 67. Network address is 224, and the gateway will be 65. okay, for the third one it is 96, right? So 97 for gateway, here it will be 98. The subnet mask is 240, 97 for the gateway. For the next PC, $99, 240, and here it is 97 for the gateway. Close it. For the D subnet, it is 112, right? So gateway will be 113. Here I am going to use 114. 248 is the subnet mask. Gateway is 113. Close it. Last one. Here it is 115. Let me add. And then subnet mask is .248. It will be 113. Close it. Okay. Now we have to assign the IP address for this interface. Okay. So this is GIG 00 interface, right? So click on the router, config, gigabit Ethernet 0/0. Here the IP address will be .1 gateway. Okay. And the subnet mask will be 192. And switch on the port. So the link is up, the interface is up. Okay. Now the router is connected to another one interface. Here it is going to be 0/1. So the network address is .64. Here the gateway will be .65. Subnet mask is 224. Okay, switch on. So this link is also up. Coming to the next router, we are going to the gigabit Ethernet 0/0. It is 96 is the network address. So here it will be 97. Subnet mask is 240. switch on. Okay, the link is up. Then gigabit Ethernet 0/1. It is IP address is 112 is the network address, right? So here it will be 113 and the subnet mask will be 248. Switch on the port. Okay, now we have to bring this link up. Okay, so the network address is 120.120. So click on this one is 0/0 serial port 0/0. This also 0/1. Okay, so click 0/0 and then our network address is .120. We can make it as 121. Subnet mask is 252. Switch on. Okay, we'll come to the next router and do for the other interface. It is 121 we assigned, it will be 122. Subnet mask is 252. Switch on the port. Okay, so this link is also up. Okay, so up to this is the general configuration that we will be doing for any of the routing protocol. Okay, so now we will go do it for the OSPF. So for OSPF, just click on the router, go to the CLA command, okay, and just enter. So you will be getting this prompt. Okay, it is in the interface. Just you have to give the command router. I'll make it as small. Okay, router OSPF 10. 10 is the process ID. Okay, this process ID is for this router. Okay, it is a reference for this router. Okay, so it is not needed that for each and every router the process ID should be the same. It can be different also. Okay, so now we are into the router configuration mode. Okay, so in the router configuration mode we are in the OSPF router configuration mode. Okay, so now we are going to assign the IP addresses that are connected to this router. That is, we are going to teach the router about its own network. Okay, so for that the command is network 192.168.10.0 is the first network, this network, followed by its subnet mask. Actually it is 0. It's not a subnet mask, it is the wildcard mask. Okay, so it is 0/0/0/63. Okay, and we have to specify the area of OSPF. Okay, so OSPF is actually you can do it in two ways. One is within the same area, or we can go for the multi area. That means we have two classification. One is single area OSPF and the another one is the multi area OSPF. In this exercise we are only discussing about the single area OSPF. Okay, that means for all the routers we have to give it in the this area number should be the same. Okay, so for the next router also I have to give the area number as 0 only. Okay, so that is the difference between the single and multi. In case of multiple area, the next router can be in another one area, that doesn't matter. Okay, just enter. Okay, so we have entered the one network connected to the router. Similarly we can do it for the next two network. Okay, so for the next network it is .64, right? .64, and its wildcard mask is going to be .31. Enter. And the third one is this E subnetwork. Okay, so it is 120 and its wildcard mask is .3. Enter. Okay, now close this. Come to the next router. Okay, similarly we are going to make the configuration for the router OSPF. Okay, so go to router OSPF followed by a process ID. I am giving the process ID here as 10. Okay, and then I have to teach about its network. Network 192.168.10.96 is the subnet C, followed by its this wildcard mask. It is 0.0.0.15. Okay, followed by the area. Since it is single area, it is area 0. Okay, for the next network, here it is 112. Okay, so 112, its wildcard mask is .7. okay, and area is 0. And the third network is 120. Wildcard mask is 3. Okay, so now we have done with the configuration. Okay, now we will check whether we are able to ping from one PC to another one PC. Okay, so first let me check within the same network PC0 to PC1, it is successful. So the next one is to check within two different networks connected to the same router. It is failed. Since it is a dynamic routing protocol, it may take some time for finding the other end. Okay, so it is successful now. Okay, so now the packets are able to start from here and are able to reach PC2. Now we will check whether it is crossing the router and going to the network connected to another one router. Okay, PC4, it is failed. PC0 to PC4, it is successful. Okay, then finally we'll check for PC0 to PC7. It is failed. As I said, it may take some time for the dynamic configuration and to update the routing table. Okay, now it is successful. Okay, hope you have understood this concept. Thank you for watching this video. Bye bye.